In this video, we're going to look at testing, hypothesis testing, but specifically comparing two samples or comparing two means or two proportions. So in the formula sheet, we're looking at this portion where two samples. So we'll be looking hypothesis test for mean 1 and mean 2, population mean 1, population mean 2. And of course, to test that, we need a sample mean from each population. And depending on the population standard deviation known or unknown, we use different formula for test statistic. And for proportions, we use this formula to find the test statistic. And finding the p-value and making conclusion is similar structure as we did before with a one sample. Okay? So only thing the major change is using different formulas for test statistic in these problems. Okay. So in this section, we're assuming that we have independent data would like to test for difference between two populations. So the reason why we test difference is if they're not different, that means they're same, right? And if they're different, one can be greater with the other. Okay. So let's look at first scenario, testing mu1 minus mu2 when the population standard deviations are known. So that means population standard deviation 1, population standard deviation 2, both of them are known. In that case, we use Z test statistic. Okay. So when we form a new hypothesis, it will be slightly different than before. We're looking at two sample tests because we're interested in difference between two groups. So for new hypothesis, difference is 0. Mean 1, mu1 minus mu2 equals 0, or we can write it mu1 equals mu2. And then alternative hypothesis, depending on the test, depending on what the problem is asking, we have three options. Left tail test means mean 1 is less than mean 2. Right tail test means mean 1 is greater than mean 2. And for two tail test, it's actually not equal. Right? This should be not equal. So not equal could mean either right, greater or less. But again, the problem will dictate which one of these tests will have. Okay, so we have to read the problem carefully. And for the formula, we use this Z test statistic formula to find the test statistic. And finding the p-value, again, it's all just same. Once we find the test statistics, you use the Z table and compare the p-value with alpha to reject or null or fail to reject or null. So let's look at an example to look at these steps. A consumer group is testing camp stove. To test the heating capacity of a stove, it measures the time required to bring 2 quarts of water from 50 Fahrenheit to boiling at sea level. Two competing models are under consideration. 10 stoves of the first model and 12 of the second model are tested. So we have 10 of the first model and 12 of the second model are tested. The following results are obtained. The first model had a sample mean of 11.4 and a population standard deviation of 2.5. The second model had sample mean of 9.9 and population deviation of 3.0. Assume that the time required to bring water is normally distributed for each stove. Is there any difference either way between the performance of these two models? Use 0.05 or 5% significant. Okay, so let's organize the information we have. So for example, from group 1, we have sample mean of 11.4 and we have I meant to write standard deviation, population standard deviation of 2.5 and sample size was 10 because we test 10 of the first stoves. Group 2, we had sample mean of 11.4 minutes, population standard deviation of 3.0, and sample size of 12. We test 12 of them. Okay. So organize information first, and let's form the statements first. So new hypothesis will be they're equal. Population mean from the first group equals population mean of the second group. And then alternative hypothesis is either way, are there any difference? So are they actually different or not? So they're different. So in this case, we have two-tailed test. Two-tailed test. So second portion, let me write it right here. We have to use test statistic. We have to find test stat. Well, in this case, is Z because sigmas are known. They're known, so we must use Z test statistic. Okay, so we use this formula. Let me copy down this formula right here. Test statistic formula equals x bar 1 minus x bar 2. So difference between two sample means. Square root of standard deviation from the first group square sample size 1. Population standard deviation from the second group divided by sample size 2. So let's plug these numbers. 11.4 minus 9.9 divided by square root of 2.5 square over sample size was 10. 3.0 square divided by 12. And for this value, I get 1.2792. Okay, so that's our test stat. Test stat. And let's find the p-value. P-value. Well, for p-value, we're doing two-tailed tests. So for two-tailed test, the p-value is 2 times probability of z bigger than absolute value of test stat. So in this case, 2 times probability of z. Well, we already get positive values, so z greater than 1.2792. So then we can't find greater than directly, so we have to do minus 2 times 1 minus probability of z less than 1.2792. Oh, let me put one more parenthesis here. So we find this from the table, do 1 minus and multiply by 2. So on the table, we can actually find 1.28 for z value, which is 2 times 1 minus z value for area left of 1.28 is 0.8997. Again, this is from the z table. Z table. So then if I calculate this, I get 0.2006. So this is the p-value. P-value. So then for the fourth step, again, we're comparing. Is p less than alpha? Is p less than alpha? Well, our p-value is 0.2006. Our alpha value was 0.05, 5%. In this case, no. 0.2 is bigger than 0.05. So answer is no. So we fail to reject H naught. Fail to reject. Fail to reject H naught. Again, this portion is all same. Only thing that has changed in this video is really the different formula for test statistic. So for conclusion, we write, there is not sufficient evidence to conclude that two store models mean are different. So not equal means they're different, right? So we're just writing this alternative hypothesis in words. And there's not because we failed to reject H naught. So now we're going to look at testing two means when population standard deviation are unknown. So when it's not known, we use T, this formula, to find the test statistic, and we use the smaller of the sample size to find the degrees of freedom. So whichever n1 minus 1 and whichever smaller, we use that as degrees of freedom to find the p-value, which will be, again, estimate for t. Okay? So let's go over this. This is, again, when population standard deviations are unknown. Use this as a test statistic and use smaller. If they're same, yeah, you can just use either one of them since it's the same. So let's look at this example. Two competing headache remedies claim to give fast-acting relief. An experiment was performed to compare the mean length of time required for value observation of brand A and brand B headache remedies. 12 people were randomly selected and given oral dosage of brand A, and another 12 were randomly selected and given equal dosage of brand B. So in this case, sample size are the same. The length of time needed for a drug to reach specific level in the blood were recorded. Brand A has sample mean of 21.8, standard deviation of 8.7. Brand B had sample mean of 18.9 and standard deviation of 7.5. Past experience with drug composition of 2 remedies permits researchers to assume both distribution are approximately normal. Use 1%, which means alpha equals 0.01, to test to claim that there is no difference between these two brands in the mean required for value absorption. Okay. So another two-tailed test. So let's look at, again, I recommend organize the information, brand A, brand B. Sample mean of brand A was 12.8. Sample standard deviation. This standard deviation is from the sample, 8.7. So we use lowercase s. And sample size was 12. For brand B, sample mean was 18.9. Sample standard deviation was 7.5, and sample size also 12. So let's form the statements. New will be no change, so they're same. Alternative, they want to see that is there no difference, or are they different? So, mu1 not equal to mu2. Okay. So then for test statistic, you write it right here. Test stat. Again, this is very important which one we use. We use T. Since population standard deviations are unknown. Sigma 1, sigma 2 are unknown. It's not given in the problem. So we use a sample standard deviation. So let's write the formula for T. X bar 1 minus X bar 2 divided by square root of S1 square over N1, S2 square, and 2. So just plug these numbers. Square root. For this, you get 0.8746. So test stat is T equals 0.8746. Again, this is important, the fact that we're using T. So then let's find, well, let's write the degrees of freedom. Use a smaller one, but both of them are 12. So 12 minus 1 gives me 11. So let's find the p-value. Remember, for T statistic, we're estimating using the table. Okay? So 11, two-tail, and 0.87 is the p-value. So let me go to the T table. Degrees of freedom is 11 right here, and 11, and our value is 0.87. So 0.87 is between these two values. So we go up. P-value for this one, for two-tail is 0.5. P-value for this one is 0.25. So we know that our p-value is between these two values, 0.5 and 0.25. So p-value for us is between 0.25 and 0.5. Or we can also write it like this way, 0.25, 0.5. Okay, so let's write the conclusion. Well, first we have to see, is P less than alpha? Well, for us in this problem, alpha was 0.01. Answer is no, right? Because whatever P is greater than 0.1. P is greater than 0.25. So it's definitely greater than 0.1. So this is P is not less than alpha, which means we fail to reject. Or let's write do not reject, means the same thing in terms of conclusion. Do not reject H naught. So now our conclusion is there is not sufficient evidence to conclude that there is difference between two means, which is, again, we're just writing H1, or alternative hypothesis in words. There is not sufficient since we do not reject H naught. Okay, so this is how we test two means when population standard deviations are unknown. So let's look at testing proportion, difference between proportion or two proportions, P1 minus P2. So for test statistic, we use Z for proportion, and this is the formula for the proportion test statistic. Here we have a P bar. P bar formula is x1 plus x2 over n1 plus n2. So number from the sample, two samples, divided by sample size of two samples, us adding them. Okay, so this is the kind of new part right here, P bar. P hat is sample proportion for first population, second population. We find the sample proportion. Okay, so let me just demonstrate with the problem. I think it will make more sense. County clerk wishes to improve voter registration. One method under consideration is send reminders to mail all citizens in the county who are eligible to register. As a part of a pilot study to determine if this method would actually improve voter registration, a random sample of 1,250 potential voters were taken. This sample was randomly divided into two groups. So here is group one. Group one, there were 625 in this group. No reminders to register were sent to them. The number of potential voters from this group who registered was 295. Group 2 also had 625 people. Reminders were sent in this case. And the number of registered was 350. So a little more. But the question is, the county clerk claims the proportion of people registered was significantly greater in group 2. Okay. On the basis of this claim, the clerk recommends the project be funded for the entire population of this Massachusetts County. Use 5%, 0.05 significance to test the claim the proportion of potential voters who registered was greater in group 2, the group that received reminders. Okay. So, again, let's organize this information we have. Group 1, let me match the color. Group 1, well, sample size was 625. And X1, X in this case would be who registered to vote, 295. And group 2, sample size was also 625, and people registered to vote was 350. Okay, so keep that in mind, and let's state the statements first, and then test it. So first, new hypothesis is proportion from two groups are same. We can also say that actually group 1 is greater or equal. For alternative hypothesis, right here, claims the proportion of who registered was significantly greater in group 2. So group 2 is greater. Okay. So then when we determine left, right, or two-tail test, we focus on this one. This one is less than the right side, right? So this is left tail test. Because the left as in is less. The one on the left is less than this one. If it was opposite, right? If this was greater, then it would be right tail test, right? So in this case, left tail because we're looking at this group 1 as a focal point. So it's a left tail test. So let's find the test statistic. Oops, sorry, I should just write one here. First step. Second step, find the test stat. Well, test stat, we use Z for proportion. And let me copy down the formula. Sample proportion square root of and p bar times 1 minus p bar times 1 over n1 plus 1 over n2, multiply by and take the square of the entire thing. Okay. So before we plug these numbers, let's find all these values, or each of these. Let's find each of these first. Okay. So make sure to keep it well organized. Well, p hat 1 is sample proportion from the first group, which is 295 over 625. P hat 2 is be 350 out of 625. Right? And then P bar is x1 plus x2 over n1 plus n2. So in this case, x1 is 295, x2 is 350. So add those two numbers. n1 is 625, n2 is also 625, which gives me 645 over 1250. Okay. And we know n1 is 625, n2 is also 625. So let's plug all these values to find the z. Okay. 295 over 625 minus 350 minus 625. Divide by square root of p bar, which is 645 over 1250 times 1 minus 645 over 1250. Multiply by 1 over 625 plus 1 over 625. Okay. So if you calculate this, you get negative 3.1129. So this is our test statistic. Test that is negative 3.1129. So then we find p-value. Well, this is left tail test. So we need to find probability of z less than negative 3.1129. Well, let's look at, in the z table, look at negative 3.11. It gives us p-value to be 0.0009. So our p-value, oops, I forgot 10, 0.0009. So the fourth step is p less than alpha. Well, our alpha was 0.05 in this problem. Yes, 0.0009 is less than 0.05. 0.0009 is less than 0.05, which means we reject H naught. Reject H naught. So the final conclusion is there is sufficient evidence to conclude that proportion of voters who registered was greater in group 2, the group who had reminders. There is, because we reject H naught. Remember, conclusion is always this idea, reject this or do not reject. Since we rejected H naught, we have enough evidence to support H1, which is proportion of registers was greater in group 2. So to summarize this video, we'll look at each example. So important thing is read the problem carefully to identify which situation we're in terms of testing two parameters. Are we doing the means or proportion? For means, depending on the population standard deviation known or not known, we use different formulas for test statistic. And for t, we're finding only estimate. For p-value, we're finding range. P is between this and this number, or p could be less than this number or greater than one number using a t-table, which is very similar to this one. So really major difference is using different formula. And when we set up the statements, like right here, we have two parameters, two proportions, or in for earlier example, two means. We don't see a number here, right? Because we're comparing two means, not a mean to a number.